Hybrid functions. Now, the main thing, just to make sure, because we got short on time, but just to make sure you understand, the thing that you really need to get your head around is 1b. 1c will follow naturally if you get your head around 1b. Okay? 1c is just your practice on your algebra and knowing how to read what a hybrid function is. But because you know the notations from 1a and 1b, 1c should be easy. Okay? The only part that you may not understand yet is power, like odd and even functions, which I'll describe that. That'll be easy to teach. Okay? It will take like 5-6 minutes. But here we go. Hybrid. What is a hybrid function? Hybrid function is something like this. Hybrid obviously means like a bit of both or a bit of something, right? So that's exactly what you see here. See, what I'm saying here is I'm saying this function, f of x, and it's not a relation, keep in mind I'm saying it's a function. This function is broken up into 3 different parts. Okay? And your aim in 1c is to understand how to look at this, and not be overwhelmed, and then sketch them individually. Now it sounds hard, looks hard, it's not. Because all you have to do is really just sketch them individually. So you look at less than 0, 0 to 1, greater than 1. And for each one, you sketch it. That's a straight line. That's a straight line. That's another straight line. Conveniently, I gave you an easy. Yeah? Sometimes you might get straight line, quadratic. Sometimes you get quadratic and a straight line. Sometimes you get 0, like it's just a 0. And so saying 0, if you have x less than 0, just means it's sitting on the x-axis. 0. Yeah? So it just means y equals 0, or y equals 1, or y equals 2. That's called a hybrid function. The only thing you're doing in the exercise is, and try to pick questions like, some of them look hard, some of them look easy, and get a feel of it. See if you can sketch this beforehand. But that requires you to know all the functions already. Okay, if you're already struggling with sketching straight lines, then obviously doing this will be really hard to calculate. Yeah? But eventually what I want you to be able to do is, how would you tackle this if I gave you an exam? Because it used to be, I haven't seen it in a while, but it used to be part of the exam where you had to sketch a hybrid function. You had to know how to write out the domain or how to start. So the best way to start hybrid functions is this. I always use the domain. I think of it like barriers, like little clumps, and I just work with the clumps. So for me, I always look at the axes first. I say, all right, so which parts do I have, or what parts have I been given? And they say x less than 0. So that's the first thing I do. I'm like, all right, well, this is 0. Anything on this left-hand side, I'm going to be drawing this graph. So I'm going to ignore that for now. I'm going to, all right, so there's a 0. That's my first mark. Second mark, between 0 and 1, but you include 0 and you include 1. So between 0 and 1, I do my axes. I just put the numbers in, 0, 1. So now I know I've got these regions here. See how I split it up into 3? Now I can see I'm going to sketch negative x minus 1 only up to this point. And then between 0 and 1, I'm only going to sketch 2x minus 1. And then between here and here. And then after that, I will then sketch half x plus half only from 1 or greater. Okay? So let's do it individually. I'm going to do negative x to negative 1. Obviously, the only endpoint I need to know is where does the line stop at x equals 0. That's all I need to know. So in this graph here, negative x minus 1, if I work it out, I'll go, all right, y equals negative x minus 1. All I need to know is where does it cross the y-axis when x equals 0. So when x equals 0, I've got y equals to negative times 0 minus 1. That gives me negative 1. So what that means is, on x equals 0, this is the x equals 0 line, I've got y equals negative 1 right here. This is where it's an open circle. Why did I draw an open circle? Because it doesn't include. It says x is less than 0. So this line is a negative gradient, it's negative x. It's going to go down and reach here. That's an open circle. Okay, I'll make it a bit clearer. I'll draw it with an open circle so it's a bit clearer. Open circle. Okay? So now when you draw a straight line, I obviously know it's a negative gradient, so it has to look something like this. To label it appropriately for year 12, I need to know what the x-axis is. So how do you find the x-axis? What do you do? Y equals 0. Because you know on the x-axis, this is where y equals 0. So y equals 0, y equals 1, 2, 3, 4. This is where y equals 0. So y equals 0, what's my x value? So we can solve that. We can say, all right, well, at y equals 0, I now have 0 equals negative x minus 1. Add 1 on both sides. And therefore, x equals to negative 1. Yes?
When you draw graphs, is the
Oh, that's true. Usually it's not that difficult to draw. Like, isn't like the hybrids are normally pretty far apart, so you have nothing to really compare. But if you make it really obvious, then yeah, you get penalized for that. Just don't make it too obvious. If it's just like approximate, fine. Yeah, so kind of like what I'm doing, I'm just doing it about an approximate there. Okay, they're not going to be pedantic as long as you label your coordinates. So right here, I would label here. I wouldn't label the corner here because it's not an endpoint. Okay, it's just, it reaches there. So I'd say -1. And over here, it crosses that point. So it's an axis intercept. So I'd write -1, 0. Okay, and then I draw an arrow to show that it continues on. So that's my first half, or 1/3. Okay, now I'll do the middle one. So if I do the middle one, now I'll do the same thing. This has 2 endpoints here. It's got a 0 and a 1. So when x is 0, clearly that's at -1. When x is 1, that's at 1. Okay, so I've been 1 in 2 times 1 minus 1 is 1. So I know at these two ends, it starts at -1 and it finishes at 1. So here's my straight line for 2x minus 1. I already know it's inclusive at x equals 1, and it's also inclusive at x equals 0. Okay, in case you're confused about how I got this, I just went with y equals to 2x minus 1, and I just noticed that the endpoints are at 0 and 1. So I said, all right, at x equals 0, you got y equals to 2 times 0 minus 1, just minus 1. And then at x equals to 1, I got y equals 2 times 1 minus 1, just 1. Okay, so that's how I got -1 and 1. -1 and 1, they're inclusive. Okay, and I've done my second third. So 2/3 down. And the last one now. Same thing again, I'm going to look at my endpoint, and it says when x is greater than 1, so when it's greater than 1, I'm going to sketch this graph. So that means my endpoint is starting at 1. That's something 1. Now half times 1 is half. Half plus half is 1. 1. Okay, so now I've got 1, and I happen to also start right here. Okay, now the question is, this is a good comparison to what Kate was saying. See here, now if I draw the straight line for half, I have to make sure that, actually, now that I think about it, I should draw this one a bit further out. This one is a gradient of 2, so this has to be steeper than this gradient. This is a gradient of half. It should be drawn roughly to show that it's flatter than all of them. So if I draw half right now, if I were to draw a straight line, I would do something like this. For this one, I might draw it in between. And this one, I might try to draw it a bit steeper. Actually, I'll do it just a bit more, so make it steeper. Add 1, and then from here, draw a flat out half. And label that as 1, 1. There you go. Okay, so that's your rough graph. Now, if I draw, I'll show you what the actual graph looks like. Actually, you can't see that with all that there. Yeah. Can you see it? There you go. Okay, so this is the real graph. Blue, you can see it's like gradient 1, steeper, and flatter. 3 regions. But that's what I got to. Okay, I've just drawn it very roughly there, but that's exactly what I got to. So if you have a look, same thing. Goes down, goes up, goes across. I'm going to show those gradients. And that's what a hybrid function is. Exercise 1C.
It was like drastically steeper if they saw that, but they just...
Yeah, that one's this one's very questionable. The way it's definitely. Oh, like if I were to do it, I would have to rub it all off again and make sure that when I draw this one, this has to be comparatively much steeper. Even if you label it, correct, that's too. Oh, yeah, it's really on scale with that one there. Yeah, like if you notice, I didn't even adjust this one here. See, that was -1. Suddenly that's 1. That's like almost 3 times. So if I were to do it correctly, I should do this 3 times. It's big down, and it's coming down, and it's further up. That's how I should be doing it. And number 2 is I didn't even look at, I haven't solved the x-intercept for this one. That's probably why this is off. So if you actually solve the x-intercept there, that would be half. So it should be halfway. Okay. But that's what I'm saying. When you're sketching it, you need axis intercepts. Use the endpoints to sketch. The hybrids aren't scary. They're not hard. They're just tedious. If I ask you to sketch that, you're like, oh yeah, I can do that. If I ask you to sketch that, you're like, yeah, I can do that. It's when you put them all together, it's tedious. You have to do it to scale. That's when it gets tricky. Yeah? But that's what 1C is about. I haven't told you about even functions and odd functions, but that's okay. Right now, I just want you to focus on 1B. If you happen to get to 1C, I'll start on hybrid functions. In the next lesson, I'll talk about power, odd and even, but that's on videos. Okay, so the one I'm doing in session 6 today, with my other class, I'll talk about hybrid again, and I'll also be talking about odd functions and even functions. And that concludes 1C. Okay, but the main thing you got to check out is 1B. What a function is, what a relation is, how many types of relations there are, how do you do the test. Those are the most common questions you get in exams. Okay? Yeah, absolutely. Yeah. Label the x-axis. Should have been half there, half 0. There we go. All right, I'm gonna conclude this video because, oh wait, we still got 10 minutes, don't we? Am I right? Was my watch off? No, my watch. Maybe I can just quickly show you odd and even functions. Let's go. Let's go. Where's odd and even? Yes, that's it. Just the second part and that's it, guys. All right, odd and even functions. Like I said, I can do this in 6 minutes. So here we go. Odd and even functions just by definition. Here we go. Normally I get you to sort of brainstorm this x squared and x cubed and start seeing the difference because obviously even and odd, or odd and even, that's 2, that's even, 3 is odd. There's something as a pattern if I keep increasing the value. So x squared to x cubed to x4 to x5 to x6 to x7, there's a pattern. Now, what is the pattern? So let's have a look. This is an x squared. This is an x cubed. This is an x5. This is an x4. Actually, no, wait. It's like this. There we go. What's the like main thing that you can see already? What's the difference between the two? Odd and even. Say it again. Yes, that's it. That's what I was going to say too. Okay, so not only when you square it, you're only going to get positive values, hence why they're all positive and above the x-axis. Number 2 is they're symmetrical. Whatever's on the right-hand side is the same as the left-hand side. That's generally the properties of an even function. Not necessarily for all, but that's generally the properties. Okay? Whereas in odd, we call it asymmetrical. Because it is symmetrical, it's just reflected twice. So it's reflected to this side and then reflected upside down. Okay, so it looks like this. But it's the same values. If like 3 cubed is 27 and negative 3 cubed is negative 27. Same value, different direction. Yeah, so these are asymmetrical. Now, that was just on an observation point. But in terms of what you need to know, just 2 things. Copy this down. This is how you tell if it is an odd function or an even function or neither. So the questions you're going to get in that exercise, last part of exercise 1C, will say, state whether it's neither, odd, or even. Okay, so how do you test that? Literally by this property. That's all it is. An even function means it doesn't matter what you put in, it's always going to be positive. So whatever you put in, you're always going to get positive. That's what Kate said. It's always going to be positive. Whereas, because it's not symmetrical, therefore it's going to be asymmetrical. For odd functions, whatever you put in that's negative will become a negative function. Okay, so for example, 3 cubed is 27. You put in negative 3, it becomes negative 27. Same value, different direction. Okay. So I'm going to do an example. How do you test a function is odd or even? I'll do a question so you can see, but this is all you need to copy down, literally. That's all you need to do. You just got to test. If you sub in negative x, do you get negative f of x? If you sub in negative x and you get a positive f of x, then it's an even function. Okay. All right. So let's do an example. Let's have a look. So definition's still there. If you haven't copied it, it's still on the right-hand side there. Let's do C. Yeah, I'll do C. Actually, let's do F because it has all more terms. Okay. Let's do F. If the question is state odd, even, or neither, let's do F. So f of x is equal to x to the power 5 plus x to the power 3 plus x. Your question is, how do you know if that's odd or even? There's only one thing you got to do. find out f of negative x. If the answer is the same as f of x, it's even. If the answer is the negative of, so imagine all this is negative now, then it's odd. If it doesn't fit either, it's neither. Okay, so here, let's do the test. So if I sub in now, I'm going to substitute negative x in. So what I'm going to do is I'm going to put negative x into the power 5 plus, I'm going to put negative x in to the power 3 plus negative x. What this gives me now, negative x to the power 5, what does that give me? Negative x to the power 5. Because remember, anytime you do it to the power of an odd number, it ends up being, it stays negative. Yeah, so like negative 1 cubed, still negative 1. Negative 1 to the power 5, still negative 1. Yeah? So this is still negative x to the power 5, and this is still negative x to the power 3, and this is still negative x. Now if you look at that answer, this is exactly the same as saying negative of f of x. Because if I put a negative in front of this, this becomes a negative, this becomes a negative, this becomes a negative. That line will be exactly like this line. Therefore, this is an odd. Does that make sense?
How do you tell if it's neither?
It's odd. Let's find one that's neither. Now, this is even. This is odd. I think this could be... Yep, this one. C. Let's have a look at C. C, f of x is negative 2 of x cubed plus 7. True? So that's f of x. Now, if you want to find if it's odd, even, or neither, test it. So how do you test it? We do f of negative x. We're going to substitute negative x in. So you've got negative 2, bracket, negative x now, plus 7. Now this works out to be negative 2 times, now this is going to be negative x cubed, because negative x to the power cubed, power 3 is negative x cubed, plus 7. So now this works out to be positive 2x cubed plus 7. Now this is your first question. Is this equation the same as the original f of x? No, because that's a negative and that's not. So it can't be even. But then if it's to be odd, that means if I put a negative here, negative f of x, it should be positive and this should be a negative. But if you look at this one, this is positive, this is positive. So it's not odd and neither is it even. Does that make sense? I'll do the odd one. I'll show you what I mean by it should be. So I'll do it in blue. I'll do the one in blue. So you see how I said odd here? Odd says that it has to be negative of f of x. Now this is f of x. So if I write negative of f of x, what I should be getting is negative of negative 2x cubed and then minus 7. But this actually ends up being 2x cubed minus 7. See what I mean? That's what this test is. See, this question here says, if it's odd, you should have a negative in front of f of x. Meaning, imagine there's a massive bracket around all this and you times them all by a negative 1. If I times this by negative 1, I get positive 2x cubed. If I times this by negative 1, I get a minus 7. So this is negative, this is f of negative 8. That's odd. This is even. This doesn't fit in either. So that doesn't look like this, and neither does this one look like this. Therefore, this is neither. That's how you test it. Okay? Okay, so we're just testing. We're just checking. If it looks like this one, that's odd. If this one looks like this one, it's even. But because this one is on its own, it's neither. So that's what the mathematical definition is. All you need is just that. And you're just testing by putting negative x in. Does it look like that or does it look like this? If it doesn't look like either of them, it's neither. And that's 1C. Okay, exercise 1C. Hybrid functions, odd and even functions, and that's it. But the most concept you see, the one that we took a lot of time on, was 1B. Try to understand 1B. That's the big one. Do 1B. Thank you, Year 12s. Remember to join Schoology. Videos on Saturday and Sunday. Try to get them out ASAP before I go to